Hello YouTube, this is another repair video. As I promised, I would try to get back into more of a, not really a routine, just a more consistent flow of videos coming through. And what I have today is, and this one doesn't exactly have the spin issue, but wanted to go ahead and show the way that I've discovered to pull these apart to service issues such as stuck and slow moving PS4 fans. And the way that you do it is very simple. You take this fan and you're going to just pull it apart. Now, to do this, and it works different on different fans because they, I guess, have changed the latching a little bit, but the general principle is the same, is that they should all pull apart, and you want to try to grab and apply as even pressure as possible. And I'm going to even support the center plate so that it doesn't bend as much. And ideally, there would be a tool for this. I got to imagine the manufacturer has one. And we're going to pull it, and it should pop. And it does sometimes catch on that edge and pull that, but that doesn't cause any issues. And so you get this kind of slow, deliberate pull until it comes to its breaking point and it snaps out. And the way this works, if we look down inside of this with the microscope, let's turn this on. Alright, so you can almost see if we can get that edge right. There we go. That there is a grooved slot there for this fan to come through, and it just kind of snaps into place, and then the magnetically driven charge keeps this thing focused and balanced. Now, when you pull this apart, until some type of tool is developed, and I haven't seen anything yet that isn't the manufacturer's own specified tool, and again, they don't show that to us either, but this makes cleaning of this particular device much more simple and allows you to get much more in detail and do servicing like you would on a standard computer fan. But if we take a look in here, we can see a dust buildup inside. Normally what you would notice on fans that are sticking is that you started to accumulate rust here on your little spindle and on this magnetic core, or maybe it's magnetic. It's just whatever it does in its changeover from the coils. But again, you don't want to scratch this, so you want to be gentle with it. I would probably first suggest using a Q-tip, and for mine, I don't even really need anything, but I could add isopropyl. That's not going to affect it. Now, if you notice that you have rust, you will be able to clean off a certain amount of that with a Q-tip and isopropyl, but it's only going to be surface level. What you really need to get, and I don't have any with me, is a treating agent for that, and I'm sure there's probably that's something that is geared more towards the practice. I'll try to look that up and maybe see if I can get some in the future. And while we're here, we can really see all this dust. But now that it is separated from the electronics, which is something I couldn't do in the very beginning until I figured out how to get these apart, is we could dump this into an ultrasonic cleaner and not have to worry about water accumulating inside of this coil and not properly drying out. And you don't want to heat it up too much because then you start to mess with any lubrication that was on it. Of course, isopropyl would do the same thing, but we can add a little bit of lubrication to the spindle. I probably don't recommend lubricating your magnet just because it would have to be such a thin layer. And like I said, there are some lubricants that are made for that, and then they also contain a rust inhibitor, and that is probably what you want to use. In fact, you know what? I wonder if some good old-fashioned Lucas oil, which contains all of those properties and is highly synthetic, if it would be a great alternative there. We might have just, and I'm sitting here doing all this under microscope and you can't see any of that. Let's go back to the Logi Big only. So all I was doing is just cleaning and swabbing with this Q-tip, applying a little isopropyl, and started to have the idea that rather than looking for something specific, we find something that's very near and similar to, and a lot of automotive products are sold for automotive use, but actually are the same products, just cheaper, that would be used in electronics use, such as like electronic contact cleaner. Spray bottles of that are extremely expensive on their onesie-twosie count prices for the electronics industry. But buying those off an automotive rack, you can pick up that same bottle for about $4 to $6. Now, more of those tend to have more noxious fumes to them, so using them in a well-ventilated area, because they're designed for mostly, shop and home outdoor use, whereas electronic products are designed for use in a lab, so they're going to try to be as environmentally and lung-friendly as possible. So like I said, you could drop this in an ultrasonic. Most of you don't have one of those, so I'm going to show how to just do this with a Q-tip. And I wouldn't have Lucas oil on hand for my work desk either, so that part will have to wait as well. But I think I'm definitely going to try that solution because it contains all the same principles that we want. There's rust inhibitors, rust removers. Now for rust that's trapped inside, it should encapsulate it and put it into like its own little porous bubble, and it tries to prevent it from creating friction. But again, we also have to use a very thin layer of this because it's going to build up very quickly to meet these edges, and then you get the friction of that oil actually against these two surfaces, and you get slowdowns from that, and you could get splash and other things that we just probably wouldn't hurt anything, but we're going to try not to have those things happen. Now let's see if we can make sure we're straight as possible. And as you see, this is a plastic mounted unit. It does look like there is metal throughout, but this plastic surrounds that. I have had times where I've tried to pull these apart and it actually snapped and broke. So again, they're designed and engineered so that unless you're doing them specifically the way the manufacturer indicated, that they will fail if you're not careful. It took me a while of figuring out how to grab them and how to pull them apart without breaking them before I was successful. And just for those that aren't aware of how these work, this does not spin. All your spin is on this. There's a pulse charge that goes through this, and it changes the wave pattern or the direction of this charge to keep a magnetically driven motion, and that causes that spin to take place. Now we do, like I said, I'm not going to do the Lucas oil attempt, so we're just going to use some good old silver lube, multi-purpose synthetic grease. Don't need a lot because we're not going to put it on anything other than that metal piece to keep us free floating and spinning. But if we had rust inside of this, we'd want to clean that up because rust is going to continue to grow, and eventually you're going to be right back at the same place that you were. And the more you take this apart, the more likely it's going to eventually break down because of the design. Most fans, well, at least fans of the past, there was always a service port for taking them apart, and they use this kind of like, I forget what the ring is called, but it's a tang, and you use a special tool to pull it apart. Other people just use pliers or a flathead, and the industry has gone away from that because who knows why, other than the fact that that was user serviceable, and from what we've seen, the trend is make it so that no one can fix their own stuff and everything has to be replaced. Alright, so as simple as that, we just spun a little bit of grease on it, and that's going to make it so that we've got as good of a frictionless seal as possible. And then once we get this on, we're not even all the way down, but what you should see is that your fan spins pretty freely. And once we're down and on there, we should again have a very nice free spin, less wobble than it had before we locked it in. Now that it's locked in again, it's not going to pull out. It's in that same lock position that yours is going to be, and you're just going to take it and you're going to pull apart. Remember to keep as even as force as possible and try to pull your pressure here as even as possible. And if you notice that you feel like you're warping it, stop what you're doing, reset, grab another way. I had to break a couple of these to figure it out. To even figure out that they simply just pulled apart, I actually took one where I just drilled it all the way through, got down to the individual components until I understood the mechanics of how it worked, and that's what exposed to me the fact that it should just snap off. And then, like I said, once I figured that out, it was about 2 or 3 that I broke before I found my own little right way of doing this. And really, it's as simple as just keeping that pressure even. So as long as you can hold it from as many sides as possible and give a nice even pull, and I just kind of slowly build up my force until it just kind of gives up a pop on me. As you get more comfortable with it, you could probably get a little bit more of a snatch, but I think the harder and quicker you try to do it, the more likely you are to break something. So again, go slow, go steady. It should come off, and if you found that this worked to completely remove or alleviate your issue of a sticking or stuck fan, feel free to let us know in the comments. We'd like to get more confirmation than just our own personal experience. If you beat me to the punch on making a tool for doing this perfectly, by all means, certainly post that in the comments. I would definitely be interested because I'm not sure when I'm going to get a chance to try to engineer something that fits into all the crooks and crannies. As a note for anyone that is a maker, a tinkerer, and would like to try this, the issue that you run into is that this fan, it is, what is that, convex? Yes, where it goes under. Going back to geometry class here. Anyways, there's a dip. So the fan, as you can see from these edges when you look at yours, it's actually going down. So you have to get a tool that can actually reach kind of in and then almost really flex. So it's probably, the tool would have to start out very thin and pliable so it can follow a natural ridge line, and then eventually thicken and stiffen up to give you more of that control that you need to pull apart. But there may be a different way to do this, and I just haven't thought of it. It's probably also even very possible to design a tool that would create pressure from the backside and just simply needs to go down onto that edge plane and then uses this back plate as its kickoff point, kind of like a tool that is used for doing the what is that, the tensioner pulley on a 350 engine. So again, any makers out there that want to try to attempt something for that, there's probably a ton of people that would love to be able to pull these apart and service them rather than having to buy new, because these fans certainly have a lot of life in them, except for the fact that when they're needing a routine scheduled maintenance, which every fan eventually does, the design of it has made that almost impossible. So again,
That's what I've learned about the PS4 fans. Hope that it's helped you out. If you got any questions, feel free to post them in the comments below. If you like this video and would like to see more like it, go ahead and hit that subscribe button and hit the notifications bell so that you'll get reminders as I post new and additional videos to this channel. Take care and see you all on the next stream.